I, you know, I'm trying to continue to record these videos regarding schematics and stuff. And I know, Danny, you asked about the other two videos, and they're still being edited. These videos that I'm recording for the wiring diagrams and stuff like that is going towards the book and stuff that Brandon and I are writing. So we're editing some stuff out of these videos. We just haven't uploaded them yet. But once they're ready, they'll be up soon, including this video too. Um, so I know that the direct drive washer is an old washer. It's not even being made anymore. But the idea of the class is really to explain different parts of the diagram. And I think in the last class that we had on the wiring diagrams before Brandon did his business classes, is we talked about this section here about the water temperature selector switch and how it worked in relations to the water valves. But I want to get also into the timer sequence chart. Even though a lot of machines now are coming electronic, the computer board still functions like a timer. It still has a cycle, and it still sort of works like a timer. It's just an electronic timer. So let's go through this diagram, break down different parts, and if you have any questions, don't hesitate to ask. Let's get into it. Um, Here's the wiring diagram. There's a lot of stuff in here. When I look at a wiring diagram, I don't just look at the lines and the connections of the lines. I look at everything. I sort of read this like as if you were just picking up a book and reading a chapter out of a book. And I look at this, and I've never worked on a machine before. I could look at the diagram and tell you how a majority of things operate. So, a couple things I want to point out to you is, first of all, the different types of switches that we have on the diagram, and we'll get into the timer chart. Is the 1 second? I'm sorry. So these switches that have numbers on them, all of those switches are going to be found inside of the timer. Now, usually they are bold and more heavier drawn than, let's say, like here's your lid switch up here, and I'll just highlight it for you, the lid switch and your water level switch. If you look, the only other switch that's drawn in bold that is not part of the timer is this temperature selector switch here. That is drawn bold, but it is not inside the timer. But usually all timer switches are drawn heavy lines, and they have numbers to indicate each switch inside of the timer. And we'll talk about this in a little bit. Is that notice that there are two number 7s and two number 14s. And a lot of you guys are probably not old enough to remember the old Whirlpool belt drive washer. This washer was designed to replace that washer. When I went to school in the 80s, I'd say 1982, my teacher had a washer called the Design 2000, which was this direct drive washer. Um, but anyways, when Whirlpool made this washer, the first thing that they did is they tried to keep the colors of the components the same color as the belt drive washer. Like blue was the high speed in the motor, orange was the low speed in the motor, the start was yellow and red, sometimes yellow and black, but all the colors were the same. And on the old washing machine, the washer had two solenoids on the transmission. One was for agitate, one was for spin. And the timer switch number was 7 and 14. 1 second. I was trying to bring some up and someone came in. So if you give me 1 second here, I'm going to bring up. Sorry about that. Let me just get this image here for you real quick. And I got it from Mr. Samurai. We're members on his site as well. But if you look at this, this is the old belt drive washer. And I just want to point a couple things out because remember, the more you practice on diagrams, the easier they're going to be to read. But if you look right here, You see blue goes to the high speed on the motor, orange goes to low speed, and number 7 here, the timer switch, is agitate. Number 5 in the timer was the high speed in the motor, number 6 was the low speed, and number 14 down here was the spin. And the only reason why I brought that up is if we compare them to the direct drive washer diagram, and I'll move them side by side, you see number 14 down here in the bottom on the right goes to the spin solenoid. And if you see number 14 here, we have 2 of them. That is for the motor to engage for spin. And then the number 7s are for the motor to engage and agitate. And we'll break that down when we look at the timer chart in a minute. But just wanted to point things out on the diagram. When you're troubleshooting and you're trying to read a diagram, understanding how power goes through this diagram to make that part work is the first thing we need to do. So let's take a look at some other parts of this diagram, and then we'll break down some of the circuits. So here again, we just have timer switch. Sub-interval is still a timer switch. Don't know why they drew it separately. Internal connection and harness wiring. That is like if you see this long line here, T, which means the color of the wire coming from your water level switch, goes into the timer. But that one wire feeds 3 different switches here and another switch, number 13 on the left here. So we got 1, 2, 3, 4 switches, all fed by this one wire in the, one second. I have to leave this open. Okay, so this one wire goes into the timer, and there's a single piece of metal inside that timer that actually goes to like 4 different switches in this wiring diagram. So when you are looking at the circuit and you see a heavy bold line, even though this is a timer switch here, look at how this switch, 5, 5A, 14, and 7, and 5H all connect together. And that's internally in the timer. So that's what that heavy line is showing you inside the diagram. Now let's go. One other thing I want to point out is this X. The timer switch may be open or closed. I don't know why. I mean, if it may be open, then draw it open. If it may be closed, draw it closed. But I've seen this in other manufacturers. It just means that switch may not close for the whole time that timer's engaged in that one point on the chart. And I'll explain that in a minute. But also timer steps are 120 seconds in duration. And I'll break that down. What does that mean? So let's take a look at the timer chart. This is the whole timer chart for a Whirlpool direct drive washing machine in the diagram I showed you. And I blew up this one side. I'm going to make it a little bit bigger here. And I have it in a PDF version for those of you that weren't able to get a copy of it. But let's break down all the parts of the timer chart and explain what is going on here. So if we look at these horizontal lines here, and I'll just try to draw as straight as I can. We look at this horizontal line right here. Oh, that's not good. Let me try one more time. This horizontal line here are considered steps. And if you look here, we got 1, 2, 3, 4, 5, 6, 7, 8. Those are called increments. And when a timer itself moves, you can't really just sit there and watch the timer slowly moving on its own. The timer goes to a point, and then it takes 120 seconds before that timer moves to the next step. And that means that that washer, when you put it at this point, that timer is going to do whatever it says here. It's going to fill or agitate on the high speed for 2 minutes, and then the timer is going to go click, and it's going to go to the next step. And if you see on the very first and second step here, that is going to be 4 minutes before it goes into fill and wash again. And the reason is that this is just an additional wash time. If you're really doing like really dirty clothes and stuff, it just extends the time. But if we looked at this whole wash cycle, that wash cycle ends here and begins here. So how much time, can anybody tell me, how much time is this machine going to agitate or wash when it is turned on? Does anybody know the answer?
Would that be 10 minutes?
Well, it's the 10th increment it goes into drain. But remember, each increment is how long? 120 seconds. That'd be 2 minutes. So it's 2, 4, 6,
24,
8,
20 minutes.
10, 12, 14, 16, 18. And between the
Is it 20?
18th and 20th minute, it would take and go to the start draining, for example. So what's going on the right hand side here is telling you this is what the machine's going to do. Now, okay, I see that's what the machine's going to do. How do I relate that to the machine? How do I look at that the machine? So I'm going to go to another slide and then come back and forth to this here. So if we look at this washing machine here, and let me zoom in on that for a second, is you have to look at the timer cycle here, and this is how we look at it. So we have several cycles here. We have a normal cycle, we have a permanent press, we have a delicate hand washable, which is the same cycle, and then we have a quick wash. So if we look at this, normal is also called heavy. Well, here's our normal cycle. And from here to here, this point to this point, and I'm going to mark it with a darker line, from here to here, this being the beginning of the cycle, and then it goes through all these steps till it gets to the off position here, and that's when the cycle is going to end. Well, this beginning point right here is going to be right here. All right. So if I picked out a point right here, the ending of that wash cycle, roughly where do you think it would be on this dial? So I'll give you a hint. We start here. We're starting right at this point here, right at the beginning 15. Hold on just 1 second. I got the volume so loud on my phone when you guys are talking. I'm getting a feedback. Let me just adjust the volume here for a second. I have the volume way too loud here. All right. What did you guys say?
Was in the middle?
Well, if I put some dots here, and the first stop being 1, 2, 3, 4, 5, where do you think that spot would be? Count the dots from the top to the bottom. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are just dots so you can reference the point. Where would this dot be in the cycle? Right here. Where would I be in here? Okay, well, I see you all like, well, I don't know. If you look from here to here, it's going to start to drain. What cycle happens at 12? The rinse cycle. Okay? Well, the rinse cycle's right here. So this is the 12th increment in the timer chart. And I'll explain it in a minute. And it just before that, I'm right about here on the 10th increment, just before the rinse starts. So right about here, the machine's going to start draining, and then we'll get into the rinse cycle. Okay? So that rinse cycle is how long? It's 2 increments long. Okay? And that is going to start filling with water. Well, what are we doing from 10 to 12 is we are draining and the machine's going to spin. So between 10 here and 12, right about here, the machine's going to start draining, and as the timer moves to here, it'll stop spinning, and then it'll start filling with water. It's going to agitate again until it gets to this high spin right here. So where do you think that is on the chart? What increment would this high spin be on this chart? Take a minute and look. Any guess? How about right here? Right here, it's going to spin high. The step just before it, it's draining, and then the step below it down here is spinning, and that's right at that point. So what I'm trying to show you is that this chart starting at the beginning starts here, and if you went down this entire chart to the end right here, you would be right here at the end. As the timer goes around in this direction, it's going down this way. So the first cycle is from here to here, and here's our first cycle. And then what does it say right there? It says off, and that's this off position right here. After that off, we're going to go into the permanent press cycle. And here's our permanent press, P press. Starts right here, and it ends right here, which would be at this point in our cycle. So if we look, how many increments is this wash cycle? 1, 2, 3, 4, 5, and you see that's a number 9. That 9 means that's a 9-minute wash, and this is actually, 5 increments, which would be just about 10 minutes. So if we look down here, here's cool down and pause. If we look right here in this cycle, we have a cool down, and we have this position right here where there's a pause. It says a half tub drain. So we could follow this dial all the way around and come back to the other end. If we were to take and coil this up into a circle, that's how this would work. This is telling you what the switches are doing at any given point. Now, I did the math this morning. I'm going to open up an Adobe file, though, that is a little bit easier to see. But on these step angle degrees, I just wanted to show you, I never really looked at it before. But if you look at all these numbers on the left-hand side, and this diagram is a little bit easier to read, I just can't draw on it. If you look at these numbers on the left-hand side, that's 7 degrees, 7 degrees, 6 degrees. If you add all these up, all the way up to the bottom here, all the way to this one, what do you think that number would add up to? Just a guess.
360?
That's correct, because it started here and it came all the way around, and it'd be 360. So if I went to this increment right here, and I'll go back to the PDF one because it's a little bit easier to see. If I went to this increment, like, let me pick out a point here. I went to this increment like right here, this number 7 right here. Well, I would say 1, 2, 3, 4, 5. That would be 5 times 10, be 35 degrees. So I would be, if this was 0 degrees, 35 degrees may put me, I don't know, right about here. Now, here's the question. How do I know exactly where I am here and there? It's impossible. Okay, and I'll explain that to you as we get a little bit deeper. But getting an exact point on this chart and finding that exact point on a mechanical timer is very difficult, because the timer and this piece are two separate parts that are screwed together. So it could be, 16th or 32nd of an inch, the screws that hold it. The timer could be move a little bit to the left or to the right. So this isn't 100% accurate where it's pointing at, but it just gives the customer enough of an idea to know where they are. So what's going on inside this chart? Let's go back and break down what everything's going on inside the chart. First of all of these numbers here switch 11, 12, 5, 5A, 6, 14, 7, and so forth. Those are the actual numbers of the switch. And if we go back to the diagram, there's the 5, the 6, the 5A, number 10, 7's 14. So all those numbers are up here. So each one of these columns going downward is representing one switch inside of that timer. Okay? So this timer has how many switches inside of it? If you guys could look in here, how many switches are inside of that timer? 1, 2, I'll let you guys try to figure it out.
Is it 14?
14. Even though we have
14.
spaces here, we're not using those spaces for any switches. So if we went back to the diagram, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. There are all those switches that you could find on that chart. Okay? Well, how does it work? Let's take a look. Let's move to the next point. So if you went into the very first click on the timer, and that would be right here, the very first click where the washer would start doing something is right here. That'll be the very first row on the top of that chart. Let's go to my exploded view here so we can see it a little bit better now. So if we looked at that timer, we're here right at the very first increment of the cycle. We're at the very first increment of the cycle. Anywhere we see it shaded in, the box shaded in, that means that that switch is closed. Number 11. So if you guys can take a minute and look at that first increment, and if you could write it down on your own paper, because we're going to carry this over to another screen. What switches are closed in the very first increment of this cycle? 1, 2, 3, 4, 5 different switches are closed.
11. Okay.
All right, you guys figure it out?
There's 5.
There's 5 different switches. Let's go back to the wiring diagram. All right, I'm going to bring this chart over here, and I'll make it smaller again so I can see both things on the screen. I'm going to put it behind so that way I can still show the chart, and we'll move this over here so that we can see a little bit better. So if we looked at that diagram and we're looking at the switches are closed at increment number 1, that one's closed, that one's closed, that one, and that one. We're going to follow that up, and we're going to see that is switch number 11. And now if we go to the diagram here, we want to find number 11. So those of you who have printed it, I recommend to my students is that you get a clear plastic sheet and they have like dry erase markers. I don't know if some of you guys are old enough to remember when a teacher had an overhead projector and they would write with a marker and they can erase it and everything. That's what you want is erasable marker, not a permanent one. But switch number 11 right here is this switch right here. And let's go to the next one, switch number 5. So that's this one here. Switch number 5A is also closed here. Oh, no, it's not. I'm sorry.
Yeah, it's not.
I just rubbed my eye and I got a contact. It was my eyes all teared up here. Sorry. So the next switch is closed is number 7 and number 7. And one thing to know on this washer is that if one of those 7s are closed, both of them are. If one of the 14s are closed, both of them are. And then the last one is 10.
Does that mean it's the same wire?
No, the reason why we have two of them, I'll show you in just a minute. Let's go ahead and go through the circuits of what the machine's doing, and then I'll answer your question, okay?
Okay.
I just don't want to get ahead of what I'm doing. So what is the machine doing right now? How would you know what the machine's doing? We looked at it. We closed the switches. Let's look at one more thing before we say what the machine's doing. Where is that? Here. I want to take a look at one more thing here. Let's bring this to the front. If we look at our temperature selector switch, we're set on cold, okay? So I just wanted to bring that up because we're going to have to select cold, cold. So if we look, and we talked about this last week, we have to also close this switch because that's the water temperature switch that I just showed you. And we're going to have to complete that circuit. So do we have cold, cold on the top switch here? And you're like, well, I don't know. If you look at the top switch, we have two things. We have warm cold and hot cold. These two go to this switch. This one goes to the center switch, and these three go to this switch. That means if a customer chose hot cold, which is the wash cycle is going to be hot water, but the rinse is going to be cold, any one of these that have an HC would be closed, and that was only the top one. So if we were on cold, cold, which ones or what switches would be closed in this timer, in this temperature selector switch?
Is it the bottom one?
Just the bottom one, because it's the only one that has cold, cold. This one don't have it, and this one don't have it. So this is the only one closed. So let me erase this for a second. What is the machine doing on the very first increment? Well, you have to highlight the circuit. Is the motor running right now?
No, you're on fill.
Okay, so let's take a look at this chart again. Like I said, I want to keep going back and forth to point things out to you. I'm going to bring it back to the front for a minute. So on the very first increment, what the machine's function is. This is the cycle, and what the main part of the cycle is. That's the super wash cycle. That's the regular heavy cycle. That doesn't really mean a lot, but it tells you what portion of the timer dial you're on. But if we look, the machine's either going to fill or it's going to agitate, which is also known as wash, on high speed. That's what the machine's going to do. But when you turn a washer on most washers, top load, what's the first thing the machine does?
Drain the pump.
It fills with water. The motor does not run until the machine fills with water. Well, how does that get accomplished? How does the machine do that?
Energize the water valve?
Well, how does it like tell the motor, hey man, don't run right now because we don't have no water in there. I don't want the motor to run because you're going to rip all the clothes up. So
Water level switch?
the water level switch is the one that does that. That water level switch, if we follow the circuit now, and I'll go ahead and highlight the circuit, that power comes in, and if we get at this point, this switch is open, this switch is open right now, so I'm going to go down. These two are open, so I can't go that way. And the water level switch says, hey, my machine's empty, so we're going to send power this way. And we go through 11, and guess what? I can't get through there. We go through this one, and I'm going to feed the cold water valve. And back to the power source. Let me just fix that a little bit. My hand slipped there. So, the machine's just filling with cold water, right? Is my timer running?
No, not yet.
Does anybody know why the timer's not running? I mean, we would assume that if you had a timer and you turn the machine on, we'd want the timer to run so it completes the cycle. Does anybody know why we don't run the timer right now?
Is it because it hasn't met the time yet, like the increment?
It's not the increment. We're already in the increment, and we've already pulled the timer knob out to start the washer, and water started coming in immediately. But if you know, and you all are living in different parts of the country, so have you ever been to someone's house that's on well water, and the water pressure is like super low? Um,
Mm,
I've been there, and it could take 15 minutes for that washer just to fill up with water.
mm.
Why? Because the water pressure is so low. Yeah, if this is 15 minutes for this washer to fill up,
Finish.
take a look at this. I want to show you something. You want to say something, Dan?
No, I was just talking to myself. Sorry.
Oh, okay, no problem. So if we look here, and we said what 15 minutes it would take to fill in someone's house, that's 2, 4, 6, 8, 10, 12, wait, 12, 14, 15 minutes would be here. If that's the case, how much time would the washing machine actually wash the clothes? 4 minutes. Because if it took 15 minutes to fill water, this timer would continue to advance. And after about 15 minutes, this is where the timer would be. We didn't wash all this time. All we did was fill water. If it took 20 minutes to fill, heck, we'd already be in the rinse cycle. So the point is the timer does not advance until the machine has filled up with the amount of water that we need. Otherwise, we won't give it the actual wash time that we need. Does that make sense?
So this means that we have to know the pressure of the incoming water to see if it's the proper pressure.
Well, we don't need to know the pressure, but if a customer cycle, if we looked at this chart here, and I think, okay, this is the whole entire regular heavy wash cycle, and it actually turns off at the 18th increment, which would be what, times 2 would be what, 36 minutes? So from here to here, you could actually say, oh, well, this cycle is going to end in 36 minutes. I turned it on. And like a dryer, if I put a dryer at 30 minutes, in 30 minutes later, that timer's going to shut off. Now, if I put it in the washer will shut off in 36 minutes, but that's if the timer is running all the time. Well, heck, if it takes 15 minutes to fill and you got the whole cycle's 36 minutes long, we fill twice. We fill once for wash here. Let me get my marker. We fill once for wash, and then we fill another one for rinse. That's 30 minutes. That means we're only going to wash the clothes for 6 minutes. All we're doing is filling with water. So in top load washers, front load, they tumble as they fill. But in top load washers, all of them are going to wait for water level switch or the water level control now, because the newer ones are more frequency. They won't wash or advance until the machine's filled. Because back in the day, you could also choose water level. You had a high or low water level. You choose the low, it'd fill faster. You choose high, it'd fill longer. So that would delay your time. So if you look at the left and the right, it's almost like if the machine was empty, this is what it's going to do. If the machine was full, this is what it's going to do. That's what that information means. Okay? Now, in the next class, I'm not done with this one, but in the next class, I'm going to do more of an electronic version of the same machine and explain what it's doing. So when we first turn this machine on, these are the switches that are closed. Look at number 5. Look at number 7's. They're closed, but my motor's not running. It's waiting for my water level switch here to do its job and go that way, to say that the machine is filled with water. So when the machine fills up, and the water switch goes to the full position, this is what happens. This stops running because it said it's full. And then the power went this way, and it went all the way up. Now the timer's starting to run. Let me hide this. Now the timer's starting to run, and we're sending power to our motor high-speed winding. Now, notice the timer goes through the motor overload to get to neutral. But in order to make the motor run, we need to energize the start winding and the run winding to get the motor to run. So power goes down here and goes this way, and it goes through the start winding and out. Okay, now let me make a mark here. I'm going to explain something about the motor, and then I'm going to get a little bit deeper into this timer chart. So now we're going through the motor. The high-speed winding is getting power from left to right, but the start winding, the power is coming in and going right to left through the start winding. Okay, but what if we wanted to spin? I'm not going to go back to that chart right now, just in the essence of time here. And I'm going to erase the number 7s because the difference is spin, we use number 14s. So in spin cycle, we close these two. So how is power then going through the motor? Well, we're still in the high speed, and I'll use a different color just to like show the difference, and I'll make it a little bit different line. So here power still goes, let me get a different color here. Power still goes through the high speed in the motor. And if we come down here, number 7's not closed, so I can't go this way. So I'm going to go through 14. I go through the capacitor to the start winding and out through 14, and then out the same circuit. So now I've changed the direction through my start winding. What that does is it tells the motor, hey, run clockwise. Hey, run counterclockwise. So let's talk about this motor and then get back to the timer chart. In order for this motor to run, we need to energize both the high speed and the start winding, no matter what speed is selected, or if we're in wash or spin. If we're in either one of them, we need to energize these two first. The only difference is this timer switches here change the direction of the start winding. So you all follow me there. High speed start, get energized, and these switches here tell the motor which way to go. If we close 7, it's one way, close 14, the other. Now the question I'm going to ask, your motor runs in agitate, but in spin, your motor just hums. You've unplugged the motor from, not the wiring, but from the transmission and the pump, and you got the motor just laying on the ground with the wires plugged in. 1 second, Fishing, and I ask your question. So if, I lost my train of thought. Go ahead, ask your question, and I'll get back to where I was. 404, Fishing?
Yeah, I'm sorry. Earlier I was going to ask about where does the lid switch play a role in like the safety thing where it won't spin when the lid switch closed. I didn't mean to interrupt you then.
Okay, I'll answer that in a second. Let's go back to this motor one, and then I'll get back to that lid switch. So on this particular unit now, that if I want to go one way, I go to 7 or 14. I'm telling you, the motor works in agitation, but does not work in spin. What part do I replace? You do not need to test anything with a meter. We have disconnected the motor from the transmission and pump to make sure that neither one of them were binding it up so it wouldn't run, and it was turning freely. But in agitation, the motor ran fine, no problem, no smoke, no burning smell. You put it in spin, and the motor just hums.
Is it the clutch?
The motor's disconnected from the clutch. The
Dead
motor's
switch?
the motor's just laying on the floor plugged into the machine. And it's working good on agitation. The motor's just running. It's not agitating because we don't have it connected to the transmission. But I just want to make sure that the motor bearings aren't bad. I want to make sure there's not underwear or sock in the pump keeping the motor from going. But the motor's working in wash, not in spin. What part do you replace?
The motor itself?
No,
No.
the timer. Let's do this real quick.
It's not advancing. Is that why?
No, look, if we want this motor to run, I have to energize the high speed. And I'll just do number 7 again. Here, going up, over, down, and out. And the motor's running. That's the wash cycle. Now, watch. What is the difference between the wash cycle for this motor to run and the spin cycle? And we go here. Well, the spin cycle, I go through the run winding the same way, but I go here through the start winding. What is different between the wash and the spin? Are the windings different? I mean, are we using a different winding or something in the motor? Yes or no?
Yes.
Yes.
No, I'm using the same high speed and the same start winding. I'm not using any other.
Switches are different.
The difference is the timer switches. Now, in a reversible motor, now we got different motors now because the VMW and the LG big ceiling fan kind of motor, they're all different. I'll get to those in a different time. In this motor, if it washes and does not spin, or it spins and does not wash, we have the same type of motors in our Admiral washers, our Maytag washers, our Amano washers, our Whirlpool direct drive washers. These 1 and 2 speed reversible motors, we use the same start and high. We change the way power goes through the start winding. Oh, GE2, the older GE washers. That we just change the direction we send power to the start winding, and that's how the motor washes or spins. So just by knowing how that works, I could just say, well, ma'am, I see it's working in wash and not in spin. I checked, the motor's not bound up, the motor's working good. If it works in one of the 2 cycles, motor's good. Okay, because if start or high was bad, or the centrifugal switch was bad, or the capacitor was bad, the motor would hum in all cycles. Okay, so just understanding that. Now, Danny, in answer to your question about the lid switch, that if we go back to this chart, and I'm going to bring up the chart first. Let's go to the spin cycle. All right, and the spin is, I'm going to go to this bottom spin here so I can hide it behind here. The bottom spin, we're going to go and just look at what switches are closed in that cycle, and that'd be like right down here, for example. And I see I got 1, 2, 3, 4, 5 switches closed again. I have number 11 closed. I have, what's that? 5, 14, 14. So I got 5, 14, 14.
And 2.
And 2. Now, notice I don't have either number 10 closed, so I can't even bring power through my water level switch or through these bypass switches here. The only way I can get power to my timer and my motor is through timer switch number 2. And timer switch number 2 runs into what? My lid switch. And the reason why that's done is switch number 2 in the timer is only closed in spin. Why is it called a bypass? Because it bypasses the water level switch. Because when we spin the machine, we're also draining the water out.
Right.
And if we drain the water out, what happens to our water level switch? It goes to empty, and it would never completely drain. If it used the water level switch to drain out, it would get halfway empty, and then the water level switch would drop to the empty position. The motor would say, "Okay, I'm done," and it's half tub full. So the lid switch and timer switch number 2 are only utilized on the Whirlpool direct drive washer during spin. Now, we got a lot of newer washers that have lock mechanisms. Can anybody tell me why a washer would use a lid switch over a lock mechanism? Let's first give a couple examples of machines that have lock mechanisms. Does Frigidaire use lock mechanisms on their washers? Their top loads? Yes.
Yes,
have a
laundry
locking-
center.
They have a locking mechanism on their laundry centers and their top load washers. Does GE use lid switches? I'm sorry, lid locks on their top loads. Older ones. I'm not talking about the newer ones now.
Oh,
I'm talking about ones
No.
maybe 10, 15 years ago.
no, they use the
Then
magnets.
go. Does Whirlpool, the older washers, the direct drive, use a lid lock? No. So why on some manufacturers we use a lid switch and another we use a lid lock? Now both of them, we put those switches for safety, because when a machine is spinning, it is so fast, we do not want a customer to be able to open the lid. I was always told a story back in the 80s that a technician bypassed the lid switch so the customer could use it till he could come back with the part. And the customer had the machine in the cycle and it was spinning, and they tried to add a towel. And while it was spinning so fast, the towel wrapped around the agitator, and the customer didn't let go of the towel fast enough, and it yanked on their arm, and they told me it ripped their shoulder right out of the socket. So the lid
Dang.
switch or the lid lock is to prevent the machine from spinning with the lid open. But the question I have is, why does a manufacturer use a lid switch over a lid lock, or vice versa?
Is it just a guessing here, but is it stronger? Like you can't easily unlock the door?
That's a good guess, but no, it's actually the design of the machine.
Is it a safety issue?
Well, they're both there for safety. The thing
But one
is,
can't be opened.
yeah, one can't be opened because that machine that has a lid lock, the transmission does not have a mechanical brake. Like when you lift the lid switch on a direct drive washer, what happens? You see that basket go, and it stops. That's a brake mechanism. They're drum brakes in the direct drive washer, like drum brakes on an old car. The back brakes on a car used to be drum brakes. Same principle. There's actual brake mechanism like a car that when you open that lid and that motor stops, the brake mechanism engages. It's not electrical. It's mechanical. When the motor's spinning, it pushes a lever which releases tension and the basket can spin. When the motor stops, a spring inside engages and locks the brake mechanism. But if a manufacturer does not put a mechanical braking mechanism on its washer, they must lock the lid, and the machine will have to wait until the basket slowly stops spinning. So if you wait for Frigidaire and you turn the machine off, you can hear it still slowly spinning and spinning and spinning. The lid won't open because it's on a delay to open the washer once it is slowed down or completely stopped spinning. So lid switches are there only for spin, and lid locks are only for spin. The only difference is mechanically, they may or may not have a brake mechanism to stop them from doing that. And in my next class,
Wax motor that stops. Is it always a wax motor that stops the lock, that pulls the locking mechanism back, or is it like an electronic?
Well, that when we get into the locking mechanisms, and I can add that into my lecture on this washer, because I can see right now I didn't even go through half of what I wanted to cover today. So we're going to have to, continue this class on. But in a locking mechanism, we have wax motors on some manufacturers. On the old Neptune washer, if you've worked on the front load Neptune washers, they had a resistor on the board. It was always burning out those wax motor mechanisms. But a wax motor is very similar to the Frigidaires and the old Neptune washers, but a lot of the newer machines now, when you put a Whirlpool washer into a top load washer or a front load washer into a cycle, if it's a wax motor, you don't hear it. Do you hear the lock mechanism on some of these washers go chunk and lock the door? That is
Yes.
a solenoid or motor driven lock mechanism. I know some of the older GE front loads actually had two solenoids in the lock mechanism, and one pulled up and locked it, and the other one pulled down and unlocked it. Some manufacturers actually did it in the plastic mechanism. When the solenoid engages, it locks the door, but then when they want to unlock it, they pop the lock. They unlock it and lock and move the lock lever again, which mechanically shifts it over. So not all lid locks are using a wax motor. Some of them have a solenoid or an actual motor driven mechanism that will lock the door, similar to like a self-clean oven. Very few people use that, but the wax motors are more common, or a solenoid is the most common on some of these manufacturers. So let's get back to this machine. So again, going over the diagram, I need to go into another part of this and actually break down the part and the part function. But let's take a look at this. I said both an agitator spin, the motor has to get power here and power here to make that motor start. If you went to this machine and I said if it ran and wash and hummed and spin, or ran and spin and hummed and wash, our problem is not the motor. The problem is most likely the timer or something that changes the direction of the motor. Now, what if the motor hummed in both cycles? I'll get to Ali. I'll answer your question in a minute, okay?
Then you see that the capacitor, the switch, or the motor.
Okay, so it could be the timer switches, it could be the motor, it could be the capacitor. But if you see my two green lines, the question is like, how do I test it? Where do I make the test? And so the high-speed winding, what two color wires bring power into the motor? On the high speed,
blue, orange,
blue and white.
blue and white.
Orange is actually for low speed. I haven't got to that one yet. Now, what two colors bring power to the start winding?
Red and yellow.
Red and yellow. Now, knowing it by looking at this diagram, that is where you're going to put your meter if you wanted to test this washer for not spinning. So if we had this motor here, just happen to have a motor here. We had this motor here. I know, I apologize. I looked at the internet for 40 minutes trying to find a decent picture of a direct drive washer. I'm gonna have to take my own picture. But if we look here at the motor, we're gonna check blue and white. If I go to this motor, blue is right here, so I'm gonna check this pin right here, and white would be, it's hard to tell. I think this is white right here. White and blue right there. But that's where you would put your meter to make those two tests right there. And if I want to check the start winding, that would be red and yellow. So if we look here, we got red on the end right here, and yellow, I can't even see it. Yellow's right there. There's blue, there's yellow. So this one's yellow. So you put your meter there to check power to the start winding. You put your meter blue and white to check the run winding. If you have 120 volts at both those points, you change the motor. So you have to know where these points are on the diagram as to where they are on the actual part. Now, one thing that would help you with this is blue, white. there would be a plug here, and I tried to get a picture of it, guys. It was near impossible to try to get a picture of the harness to show you what that plug looked like. So I apologize. What I'm going to do is I'm going to take more pictures of the machine I have in my shop. So Ali asked a question about 10A and 13, those switches. So let's take a look at those switches for a second here. Let me clear this. So if we go here, let's look at 10A, and that's right here, soak fill. So if we go, let's go to my here, we can see a lot better. So 10A means soak fill, and if we look, all these 10A is not even energized until we get to the soak cycle. So in this case here, we're going to fill up with water there. Now, what's the difference between soak and wash?
The speed, maybe? The speed
Well,
of the.
in soak, the motor's not doing anything. The motor's just sitting there holding the water. You just fill the tub up with water and let the clothes sit there and soak. They're not
It's not
doing
even
anything.
low speed, not even low speed.
Well, the motor's washing. Not on low, not on high. The motor's not even washing. It's just soaking, and it just allows the detergent to break down the food particles or whatever's in your clothes, so that when it does wash, it helps. But you say, well, why couldn't they just use any other cycle? They could have. Why they did it, I don't know, because if you look, 10A and 10, they go to the same thing, but it's only energized in the soak cycle. So that's the only reason why they use it. Could they have just gone through number 10 and accomplished the same thing? Because if you look, number 10A comes here, power goes here, and goes here to the water level switch, and we're still going to go to the water level switch. Well, what's the difference if it goes down here? No different. So why they put that in the cycle, I could not answer that question. Now, if we go to number 13, which number 13 is here, let's go back to oh wait, you know what? Let's go to the PDF, number 13. Let's see what it says here up here, because up here is the description of what each switch does. And number 13 is a spray. So if we look, it's only energized here, here, and here. And does anybody know what spray does? When it is spinning, it's going to spray a little bit of water into the machine, not to fill it up, but to try to get soap out of the clothes. That's all it is try to like spray a little water as it's spinning, and then it's. I'm sorry, what?
It's like a rinsing, but not like spinning at the same time.
Well, yeah, it's spinning and just shooting a little bit of water while it's spinning to help push any excess soap out of the clothes. That's all it is. So let me go over one more thing. Well, actually, I want to go over two more things. So it's going to run over an hour, guys. Not too long, though, but I just want to cover these last few things. And then next class that I give you, I'm going to have images of the machine, and we're going to talk about points and test points. And I do want to go over other brands of diagrams, and I want to get into computer ones, but I wanted to explain how the basic ones work, because you still run into these older machines. I'm sure there's still a lot of direct drives out there running and still have mechanical timers in them. Now, another thing is the cams. You see on the very, very top, we have 0, 2, 4, 6, 8, 10, 12, 14, and we have T and B. Now, let me see if I got my timer image on one of these presentations here. Lost in the screen here. So here's, there's that timer plug. So here's our timer. And if you look, here's all the color wires. And each one of these rows, and I'm just going to highlight one of them, is a cam. So if you look at the very top one, you have 10RTV2. That is one cam. Another one, another one, another one, another one, another one, another one. Now let's go back to that chart for 1 second and look at the very first cam here. I'm sorry. 0, T, and B, and violet, blue, and tan. So the 0 will call it violet, T will call blue, and B will call tan. Now, I'll explain to you what that is in a minute. Let's just take a look at this here. Violet, blue, and tan. Well, which one of these has violet, blue, and tan?
Is that a C?
I'm sorry, a C? What are you saying?
In the middle?
Yeah, that's common. This is top, that's bottom. I'll get to that in a minute. But actually, that's this one right here, violet, blue, and tan. Can you see that? Because this is violet, tan, and red. Okay?
Oh, okay.
So let me explain to you what you're looking at here. Let's see, in this timer, there is, let me move this image over. I'm going to draw a little bit on it, and then I'm going to draw something separate. In this timer, there's a round piece that goes around here. It's a complete circle. That's that 360-degree chart that I showed you. And then inside of here is a piece that rides on it. And it has two little switch things right here. I know my drawing's not perfect. And then on this pin is the other half of the switch and the other half of the switch. So we have how many pieces of the switch we have here? I'm gonna draw it in black so we can. 1, 2. We have 3 terminals. That's all one cam here, and that would be here. This would be the 3 wires: violet, blue, and tan. Okay. So if we looked at this plug here, and let's see if we can find it. This was supposed to be from a direct drive washer, so I don't know if it is or not, and it's not. But I would be looking here for like violet, blue, and tan on one end, either this end or that end. I'm going to get you guys a better picture. This is the wrong timer one. Like I said, I looked for a while now trying to find these images and couldn't find the one I wanted. So this piece, this round circle, is called the cam. And these 3 switches are cam 0. If we went to the chart here, violet, tan, and blue is cam 0. So I'm going to move it out of the way. This is 0. The next 3, if we go right to left, the next 3 is cam number 2. So these 3 here make up cam number 2. The next one, what do you think the next cam would be? If the
4?
I'm sorry, say it again.
Is it 4?
Yes, this is 0. This is 2. And this is 4. Why do we need to know this?
So you can check the cam? The switches?
Yeah, but the other thing is, though, is like this here is identifying where physically it's on the timer. Okay, 0, top, and bottom. This tells you what the colors are that are on these 3 pins. But we have something called 0 top and 0 bottom. Okay, so what does that mean? Well, if we looked at it, let me clear the lines. Bottom is always the row closest to where the timer motor is. This is the timer motor here. This whole row is bottom. This whole row is top, and this row is center or middle. That's where this TCB is. So let's take a look at something here. I know I had a thing with shapes. I could have drawn a circle nice, but I'm not going to look for it now, time-wise. So you got a circular cam. And on that cam, you may have portions that are raised up, and you may also have portions that are cut out. Okay? Now, you have those 3, what should we call it? Those 3 pins on the timer. Okay? The center one is the one that rides on the timer cam. And then right here, we got a contact. And then here, we got a contact. And this here is here. Now, right now, we're right here. We're not in the raised portion here, and we're not in the cutout. So it's in the middle, not touching either one. But if this piece was here, what would happen? This piece would go up, right? And these two would touch. And that's how it would close. So as the timer's rotating, pieces would raise this up, or we'd get into a piece that was cut out here. And then what would happen? It would drop down and make connection to the bottom. So we'd have wires. Well, let's just do this. This would be our timer. Our timer motor would be here, and there'd be gears that would rotate this. And then our wires would be connected here. And if we went back to that chart, 0TB, this is 0, this is T, and this is B. And then we look at the chart here, B is tan, so that's going to be a tan wire on the bottom. So this is a tan wire here. The center one, if we looked at it, is violet, and the top one is blue. This is blue, and this is violet. So if you were able to use the timer chart, and you see cam 0T because you wanted to check this switch in the timer 5H. 0T is physical location, and it would have a violet and a blue wire connected to it. And I know I just left you guys probably more confused than when you started, right? No? I'm waiting to see if anybody has any questions on this before I go any further. So if we looked at this timer, we have the cam, but the cam is this big. And so you have bunches of rows on that cam. And I do recommend, if you guys want to come back for part 2 in the next class, I have a more in-depth video on this timer chart here. Just give me a second. I'm looking for the video, and then I want to share some things with you guys. And would like it if you guys could watch this before the next class. Let me just get to the channel here. If you guys look at this video right here, Tech Talk Basic Electricity 101, this is in our paid member, but it might also be in the free section too. But you can see here in this image, let me get to this one here. Okay, so here you can see, and I draw lines on here, you can see this is raised up, but this is lower. This is raised up here, but it's lower here. This is raised up lower here. And these are not even doing anything. So these are the points of the switches that I was drawing you, but we're looking at it from the inside version. So as this disc is rotating, these teeth here is part of something called an escapement. The timer is moving the cam by moving it here. How long does it take for it to go from one of these here? Oh, look, the video's playing. From one of these here to another one here. How long does it take to go from one to the next increment here?
Was it 120 seconds?
It's 120 seconds. That's correct. It takes 2 minutes for it to go from here to here. And it takes 2 more minutes to go to the next one. So these switches aren't running like you see a machine constantly moving. These switches are slowly click, 2 minutes later, click, 2 minutes later, click, and that's what's happening. Now, if you could see, some of the points of these switches look pretty burnt. So this, this machine's timers had its fill, but some of these others are nice and clean. These get used more often. And that's how a switch fails. Every time a switch opens and closes, you get an arc heat and it burns. And that's what causes that to happen. So listen, I'm going to recommend that you guys watch this video on our channel for the next class to explain more detail this timer sequence chart. And then I can move on and use some comparisons to some other machines. So similarities how Maytag, GE, and Whirlpool all do the same thing on these motors. And then we'll carry this class into a more computerized machine and compare how a mechanical timer and computer timer are similar but also different. Did anybody have any questions on the diagram? Because I just wanted to show you this book and this thing that hopefully will be released very soon. But if you guys have any questions before I end this class, I'll be more than happy to entertain any questions you guys have.
Yeah, Richard, just a quick question, just a quick recap of the sequence operation, like
Yes.
simple way how this thing run on the diagram real quick. Just, the basic as
You
possible.
want to go to the diagram?
Yeah, I wanted to see that the sequence operation step by step, from the timer starts real quick.
Okay, well, let's go real quick. So this chart is telling me what the timer's doing, and these numbers are the switch numbers that are inside the timer, and they're located up here at the top. I know you can't really see it in this image, but those are the timer switch numbers. Okay?
Yeah.
So we go any further, those numbers, if you see that there's two switches in one cam, and I drew that for you a little bit at the end, and these are called increments. Horizontally, this whole row is one increment. And I showed you in the, let me just change this here.
Yeah, I got that part. I was just talking about the drawing itself, like, how from line one, the first thing it hits is this, the first thing hits, second thing hits is that. Just, quick little recap.
Okay, so then let's pick one more portion in the cycle and do that. Okay,
I know you have.
Okay, so let me clear this. And let's just pick high speed spin, increment number 11. Oops. Sorry about that. My handwriting, it's hard to draw with a mouse.
Yeah, true.
Okay, so I'm in high speed spin. First of all, how many switches are closed?
1, 2, 3, 4, 5.
Actually, there's 6.
1,
2, 3, 4, 5. Look at this. And I picked this cycle on purpose. Let's go back for a second.
It's not fully shaded though.
But what does it say right there?
Yeah, motor is off. Okay. I guess that counts too. Even if it's off position, it counts.
Well, it's off or on. So actually the dark line is on and the clear spot in between the two shaded spots is off. So what's happening is it's to help the motor. What did I say is the difference between the spin and agitate? The motor does what in order to make this machine go from spin to agitate or vice versa? What did we have to do here with the start winding? We caused the motor to do what?
Reverse direction.
Reverse direction. So if you're driving in your car and you want to back into a parking space, do you just throw it in the reverse, or what do you got to do? You're driving, right? So you got to step on the brake and you got to stop the car from moving before you shift into reverse, right? So if we look at these dots here, notice these dots are, I don't know why they did that. That was weird. Let me use a different color. But this dot is right here where this is going on, and this dot is right here. I'm having a problem. My mouse not working right. But anyways, that is in between these two cycles, spin and agitate. So that dot is indicating, hey, even though this line butts up against this line for, I don't know, 10, 20 seconds, which is all this little dark spot is giving us, is telling us, hey, The motor's going to stop running for about 10 seconds, and that'll give us time to change direction, like stepping on a brake. Okay? So let's go back, excluding that, because if you notice that I said it was a switch, and I'll correct myself that this shaded part actually is in between the cams. It's not a switch at all. So I will take it back and say apologize. It's not a switch, but it is causing something to happen with the switches. That's happening. So if we got 1, 2, 3, 4, 5 actual switches, so we got switch number 12 closed. And let me put this in the back here so I can draw on it. So switch number 12 is closed here. So I'm going to close 12. What else is closed? 5, 14s, and 2. So we got 2, 5, 14s, and 12. So what's energized right now? We come in, go through here. We got 3 ways to go. Which way do I go, or can I go more than one way?
Go down.
Well, if I go down, what happened here?
No, I mean to the right. My bad.
Go to the right, and then I can feed the timer, right?
Right.
And the timer goes through the motor. If the overload's bad in the motor, guess what? The timer won't advance either. So that's that, but we've also got a circuit here, right?
Yeah.
And so I hit number 5. I'm going to go through the motor on number 5. Sorry. We're going to go through number 5, and we go through here. Through the start winding. And the reason why I did it in a dash line is only because the start winding is not energized the whole time. It's only energized once the motor gets going. And then the centrifugal switch here in the motor will open up and take the start winding out of the circuit. Now, in the next class, I was going to go over more how the centrifugal switch works for high and low speed. Does that help?
But here, either way, if the lid switch is bad, we want to go to the next step, which is the timer motor,
well,
right?
if the lid switch is bad, the timer or the motor won't run. But would the machine fill with water?
Yes.
Yes.
Will the machine drain?
No, because it hasn't advanced. The timer didn't advance to more to
Yes
drain.
and no. It'll partially drain, because when it gets to the drain cycle, we're going to send power to our motor and our timer through here. And as long as the machine's got enough water to cycle the pressure switch up here, the motor's going to drain. So once it drains halfway, this will drop down. And if this lid switch is open, the motor and timer is just going to stop and sit there. And the customer's going to call you out and say, hey, my washer's not working. I had to take the clothes out, but it's filled with water. Okay, ma'am, is this where the timer was? No, I moved it around and it filled with more water, but it wouldn't drain out the water. So you put it in a spin cycle, turn it on, and nothing happens.
I just noticed something here. Where is the drain pump in here?
The drain pump is mechanical. It doesn't have its own motor. It's attached. I don't know if you've worked on a direct drive washer. That's that one that's got that plastic round coupling with a piece of rubber in the middle connecting it to the transmission. So it has the pump directly connected to this motor. So this motor not only causes agitation and spin, but the reverse direction of this pump causes it to drain out. Hold on a second.
The only way, like, what is a drain pump in this diagram? Okay.
It's not electric. Hold on one second. See if I could show you something here.
It's just really an impeller, I believe, kind of.
Yeah, and it's controlled by the direction of the motor. So if you look here, I don't know if I can find one where it's actually connected, but this is the pump, and you can see this D-stem shaft here in the bottom left. It slides on this motor right here, and so this motor here, which is the washing machine motor, is what is turning this pump. And when I turn one way, water will flow in here and go out the other, but if I return the other way, the water will not drain. if that makes
Okay, so you see this stuff on the older washer. Is that what it is?
Yeah, this is on a belt drive washer, but
washers?
it was made for almost 30 years.
Okay, yeah, because new washers, I guess I know about the new ones.
Yeah, you probably haven't been. Here's the washer where it's mounted on the transmission. I was trying to find this image where, let me see something. I'm searching changing a pump on a Whirlpool direct drive washer. I'm just gonna see if I can find someone. Okay, here we go. Look at this.
Hi, it's Steve.
Hi, Steve.
Today we'd like to show you how to change the direct drive water pump on your washer.
So if you look right here, this was the greatest feature. You take the cabinet off and work on anything you want to pull this washer out of
The
plus.
pump is located on the
There's the
bottom of
pump.
the motor. That's held in place with
Yeah.
two little spring clips.
Now watch this. Oh geez, I didn't want that. If the motor is running counterclockwise as we're looking at it, right? This
Okay.
hose is going to the drain. This hose goes to the
see.
pump. So I'm just pumping up towards the tub. When you watch, you'll see air bubbles come up here. But when it goes to spin, now it changes direction clockwise. So it pulls the water here and pushes the water out the drain. So our main motor is what's
Also,
driving that
inlet
pump.
hose from the tub
Wow.
area.
Yeah, the new washers you don't see that, I guess.
No, they have their own little motor, but you're going to run into this. There it is, how it's connected to the motor.
Motor.
Good old Steve came through.
Reach down.
So again, I got a lot of stuff to cover here, so I don't want this to take too much longer because this is a
Thank
holiday
you.
weekend. A lot of people there. But I will go over more of these diagrams and more of these circuits. I wanted just to break down the timer chart first, and then we'll get deeper into this. And we'll eventually get into troubleshooting of this. But this is part of the basic electricity book that I'm working on. But I'm working on 4 different books at the same time, guys. I don't know if any of you got the email I sent out on, let me just open this up here. I think I have. I'm going to open up this one here. This was chapter 3, 3 chapters, and I've already got chapter 4 done too. I'm completing one every 2 days, one chapter, but this is going to be a book for all of our paid members are going to get a free copy of this. It's going to go over what is heat, what is a compressor, what is a condenser, what are different types of heat, and it's going to go through the whole thing all the way up until we get into like actual components, and then I'm embedding my video lectures into these chapters. And then this is the stuff that I'm doing right now. I'm writing these books every day, and Brandon's helping me with creating some videos and stuff to go with all the chapters. And to give you an example of one thing that I wanted to do, let me see if I have it here. I'm doing like sealed system tools. And let me see if this is one. No, let me see. File. You know, I don't know. I'm not going to find it in here. But anyways, I'm doing one on sealed system tools. So let's just say I'm talking about a vacuum pump for a refrigerator. So first, I'm saying here, check the oil level. This is where you check it. This is where it's supposed to be. This is how you connect a vacuum pump. This hose goes to this. And this is what a vacuum pump does. So I'm going to have step-by-step images showing you, okay, first thing you do is check this. First thing you do that. How do you do an oil change and how often do you do it? So, and then I'm going to create videos that I'm going to embed demonstrating that. So that you'll have step-by-step pictures showing you do this connection first, do this connection. Okay, now let's talk about a set of gauges. A 3-fold and a 4-manifold gauge. What's the difference? How do you use a gauge? Well, how does it hook up? And so even though this is written in a format as a book, it's going to have videos, but then it's going to have these worksheets and actually give you jobs or assignments to do to practice what you've learned in the chapters. Now, some of this is geared towards my school where my students can do it with instructor supervision. Some of these jobs sheets I'm not going to recommend anybody do if they're not quite competent enough to do it, if that makes sense. But if you look here, this was what I sent out to you guys, just this part of it. I do have a lot more done. And as soon as it's done, I will send out an email link to all of our paid members, and they'll have a free copy of this. Now, this is just sealed system. It has nothing to do with like the refrigerator, ice maker, and everything else. I am writing those books as well. I'm using an old book that I had. This is the book that I learned washers and dryers from. Okay. You know, my first chapter was a lady beating clothes on a rock. Yeah, you laugh, but you know, I learned in the '80s. Look at this old belt drive washer. This was the washer I worked on in the '80s. Okay, but this goes over fabrics and everything else. But these were the books chapters that I used. I'm not going to plagiarize these books, but I'm going to use them for structure and create better images, more detailed, and then add videos to go with it. This here, we were talking about the transmission and brake mechanism, this is the old belt drive washer transmission. This thing was a beast. But this here, just to show you, the bottom half is the brake mechanism and the upper half is the clutching mechanism. Well, actually, vice versa. Clutch is this plate and this pulley, and the brake mechanism is this pad and this pad where it squeezes it and it stops the machine from running. So, like this is a mechanical brake and it didn't have a locking mechanism. It had its own braking mechanism. So anyways, I'm creating these books that eventually will sell, but for our paid members, we're going to give them the first couple of books for free for sticking with us. We know we don't have a lot of content. I was doing the website and I did not like it. It didn't look professional enough for me. I want something that when you guys read it, that you know you're getting good quality training material. You're not getting, you know, hey, I put it on a web page, read it. You know, I think it's lacking something. So if you guys got any questions, other than that, I'm gonna shut down for today. And the next class, I will continue with this direct drive, but I'm gonna go with other diagrams like the Maytag and the GE to show similarities and differences from these diagrams. I want you to be well-rounded with many different brands, because the more you have diversity, when you run up into a machine you've never seen or touched before, you will have the opportunity to say, oh, well, I know this works something just like that one, so this should be how it works. And that's how I work on stuff. I get a brand new machine I've never worked on before, but I've used past experience with other brands and other machines that made that job easy for me. So otherwise, if you got any questions, we'll cut it out for today.
Thank you, sir. Have a good weekend.
You guys have a good weekend, a safe Memorial Day too. All right.